So today we're going to go over simplifying rational exponents. Okay, we're going over simplifying rational exponents. A rational exponent is a fraction as your exponent. Okay, so your exponent is a fraction. So if I have b to the 1/2 power raised to the second, okay, if you have a power raised to a power, you can multiply those two together. Okay, so I would have b to the 2/2, and I can reduce this fraction to just be b to the first, okay, which is just then b. Okay, so we can reduce those fractions as exponents by raising them to another power. So b to the 1/2 power is a number with a square equal to b. So b to the 1/2 is just equal to the square root of b. So when you have that fraction as an exponent, it can be transferred into a root. Okay, so we can go back and forth between roots and rational exponents. So if I have b raised to the 1/n, for any real number b and any positive integer n, b raised to the 1/n is equal to the nth root of b. So that number in the denominator of your fraction as your exponent is your root. Okay? So that number in the denominator is your root. So if I have, quiet please. If I have 27 raised to the 1/3 power, that's equal to the cubed root of 27, or 3. If I have negative 16 to the 1/2 power, that's the square root of negative 16. Now since it is squaring, or taking the square root of a negative, you have that I value involved. Okay, so it would be 4i. So again, with rational exponents, for any real non-zero number b and any integers x and y with y greater than 1, if I have b raised to the power x over y, that's the same as saying the y root of b raised to the x. So that, again, denominator becomes your root, and that numerator is the power attached to your radicand on the inside. Okay, also that x value, instead of being on the inside, can also be raised on the outside of that root. Okay, same thing. So if I have 27 to the 2/3 power, that's the same thing as the cubed root of 27 squared, which is 3, and then I still have that squared value, which is 9. Or if I have negative 16 to the 3/2, I have the square root of negative 16 raised to the 3rd power. So square root of negative 16 is 4i. We'll cube that to get negative 64i. So when we're doing these types of problems, we can switch back and forth between radical form and rational exponents. So for letter A here, we want to write a to the 1/5 in radical form. Now again, like I said, your denominator number becomes your root. Okay, so this would be the 5th root of a. Okay, so I can switch from those rational exponents into radical form. For letter B, we want to write the 8th root of c in exponential form. So this one will have that rational exponent. So I still have c as my base. Since it's to the 8th root, it'll be c raised to the 1/8 power. For letter C, we want to write d to the 7/4 in radical form. So again, the number on the bottom is your root. So this will be a fourth root, and this will be d to the 7th power. Okay, you could simplify this, but we just had to write it in radical form, so I'm just going to leave it. Then letter D, we want to write the cubed root of c to the -5th in exponential form. Okay, so we have c as our base. This -5 is the numerator in your fractional exponent there, and then your denominator is your root. And again, you could simplify this, but it wanted it in exponential form, so that's how I'm going to leave it. Questions how to change back and forth between rational exponents and radical form? Thanks. So moving into evaluating expressions then. Okay, so letter A, I have -3,125 to the -1/5. Yeah.
That's way harder.
That's way harder. So what does this negative in your exponent do? Do you remember? What does it do to your value?
Imaginary.
No. It flips your number to the denominator. So that negative exponent flips this entire number of -3,125 to the denominator, and then you keep that to the 1/5 power. Now, if you want to use a calculator, you can. So if you have a calculator with you, I don't think all of them are this large of numbers, but to figure out what 3,125, 125 to the 1/5 power is, you can type that in, 3,125, okay? I'm going to raise it to a power, so I'm going to press this caret key, okay? And then I'm going to add parentheses because I want it to be to the 1/5 power. Okay, and I can press enter, and that'll give me 5. Okay, so if I have that 3,125 to the 1/5 power, it's just 5. So I'll end up with -1/5. For letter B, again, I can just use my calculator. So there isn't a negative exponent this time. So I could just type in 256, raise it to that power again. So with this caret key, put parentheses, we have to the 3/8 power. So I'll do 3/8, press enter, I just end up with 8. Questions? All right, so on the back, all the properties of powers you learned in previous lessons apply to rational exponents. Shh, we're quiet, please. Write each expression with all positive exponents. Also, any exponents in the denominator of a fraction must be positive integers. So it may be necessary to rationalize the denominator. So, before, when we were rationalizing the denominator, if it had a square root in it, that is the same. We're quiet, please. That is the same with your rational exponent. So if you have a fraction as an exponent, you need to rationalize the denominator. So in example 3, letter A, we want to simplify this. So we can just use our rules of exponents. So if I have that same base, and I have 2 exponents there, right? I have 2 of the same base. I can add those exponents together. Okay? So with rational exponents, you do need a common denominator to add them, just like any fraction. Both of the denominators are 4, so I can just add those numerators together. So I'll get 10/4. Okay, I can reduce that fraction, right? So if I have 10/4, that fraction can be reduced to 5/2. Okay, so here is your simplified expression. Okay, so your rules of exponents still apply to rational exponents. But with those rational exponents, you do need a common denominator to add them together or to subtract them. Now in letter B, if I have r to the negative 4/5 power, again, that negative in that power flips your term to the denominator. Okay, so this would be 1 over r to the 4/5. Now that's like saying the 5th root, right? So that would be a root in your denominator. It's not a whole variable. It's not a whole number. So we need to rationalize the denominator. To do that, you're going to multiply by a version of 1. Now we want this rational exponent or this fraction in your exponent to be equal to 1. So what do I have to add on to 4 to make this whole thing 1? How would I make that fraction equal to 1? 1/5. So I'm going to multiply the numerator and denominator by r to the 1/5. Because that way when I multiply straight across in that denominator, I'll get r to the 5/5, okay, which is just r. So that's rationalizing that denominator. So here, I'd end up with r to the 1/5 over r to the 5/5, which again is just r. So we'd have r to the 1/5 over r. So even with your rational exponents, you want this to be, say, like r or r squared or r to the 7th, something like that. You don't want that fractional exponent in that denominator. Questions on example 3, either A or B? All right, so when simplifying a radical expression, always use the least index possible. So using rational exponents makes this process easier, but the answer should be written in radical form. So if we change it into rational exponents, we need to change it back to radical when we're done. So what they're kind of saying, if I look back at example 3, letter A, we reduced this fractional exponent, right, to 5/2. Okay, so we can do similar things here with these ones because we want it to be the least index possible. So I'm going to change each of these radicals here into rational exponents, just like we did on the front. So if I have the 4th root of 32, I could change this to 32 to the 1/4 power. Okay, that would be over, since this is a cubed root, this would be 2 to the 1/3 power. Now with your powers, you need like bases to combine those exponents. So can I change 32 into a 2 somehow? Yes. So if I change 32, if I change it to 2, that would be raised to the 5th power. Okay, so if I take 2 to the 5th power, it is 32. Now I'm doing that so I have common bases in the numerator and the denominator. And I still have this 1/4 power. Okay, so all I did was change this 32 here into 2 to the power 5. Now that's still over 2 to the 1/3 power. All right, so from here, if I have an exponent raised to an exponent, I can multiply those together. So this is 2 to the 5/4 over 2 to the 1/3. Okay, now I have common bases. Okay, I need common bases to combine those exponents. But with those fractions, if I need to combine them, they need to have a common denominator. I have a 4 and a 3. Okay, so to change those into common denominators, I'm going to multiply both of these numbers here, 5 and 4, by 3. So I have 2 to the 15 over 12. And you'll see why in a second here. This exponent then, this 1/3, I'm going to multiply that numerator and denominator by 4. So I have 4 12s. Now with your rules of exponents, you need that common base. I have that, it's 2. With fractions, you need common denominators to combine them. Okay? With your rules of exponents, I can take this numerator exponent and subtract that denominator exponent. Okay, so I can take my common base. The numerator's exponent is 15 over 12, and I can subtract the denominator's exponent of 4 over 12. Okay, when I do that, I still have 2 as my base, and then I have 11 12ths as my exponent. Okay, now once I get to this point, I can't reduce that fraction in that exponent any further. So I need to change it back to radical form now. Okay, so that denominator in your rational exponent becomes your index. Okay, so this is a 12th root of 2, so your base stays the same. And then that numerator becomes the exponent within your radical. And that would be your simplified answer. Questions? All right, looking at letter B then. Okay, letter B, I have the 6th root of 4x to the 4th. Okay, I want to change this into rational exponents. So since it's a 6th root, each of those terms will have the power of 1/6. So I'll take 4 to the 1/6 power. And then x to the 4th is also raised to the 1/6 power. Okay, so again with your exponent properties, I can multiply those two exponents together. So I have 4 times 1/6. So we still have 4 to the 1/6 power, and then we have x to the 4/6 power. I can reduce this fraction. Okay, so I still have 4 to the 1/6, and then I'll have x to the 2/3. Okay, I just reduced that fractional exponent there. Now, when I have a number like 4, I can also think of that as 2 squared, right? Okay, so whenever you have like a perfect square like that, or if you have, say, 8, you could write that as 2 cubed. Okay, you want to do that so it helps you simplify these a little bit. Or if you have 36, you'd write it as 6 squared. Okay, those types of things to remember will help you reduce these rational exponents. So here, I can change this 4 into 2 squared, and that's still raised to that 1/6 power. And then I'm going to keep this x to the 2/3 power. I can again multiply those exponents together. So I have 2 to the 2/6 power and x to the 2/3 power. Now again, I can reduce this fraction. So I have 2 to the 1/3 and x to the 2/3. Okay, so now both of my rational exponents have a 1/3. Okay, that means it'll be a cubed root.
2x. Is that the answer?
No.
No. Why not?
So I can change this back into radical form. Okay, so this would be the cubed root of 2, right?
Sure.
And this would be the cubed root of x squared. Since both of those are a cubed root, you can combine them since it's multiplication.
Okay.
So we have the cubed root of 2x squared.
Wow, that's confusing.
Why is that confusing? After I do one more problem. Okay, so you want to be able to reduce these rational exponents as much as possible. All right, last problem here. We have y to the 1/2 power plus 2 over y to the 1/2 power minus 2. So this is kind of like what we were doing last week, where we had to rationalize that denominator by multiplying by the conjugate. Okay, so your conjugate again, if there's subtraction between your two terms, you'll make it addition, and vice versa. So here I need to rationalize this denominator because there's a square root in it. So I'm going to multiply by a version of 1. Now that version of 1 is the conjugate. So it's going to be y to the 1/2 plus 2. Okay? So I'm using what was in the denominator and I'm doing the opposite sign. Okay? So plus. Over, again, y to the 1/2 plus 2. So that's my version of 1, and we're rationalizing that denominator. So on the top here, you do need to FOIL it. Okay, so we have our first terms, y to the 1/2 times y to the 1/2. That gets y to the 2/2, right? I just have to add those numerators in their exponents. Then I have my outer terms, so y to the 1/2 times 2. So we have 2y to the 1/2 power. Our inner terms, we have 2 times y to the 1/2. So again, plus 2y to the 1/2. And then our last terms, 2 times 2 is 4. Now in the denominator, since I'm multiplying by that conjugate, you just need to multiply your first terms and your last terms together. Your middle ones will cancel when you FOIL it. Okay, so if I multiply y to the 1/2 times y to the 1/2, I get y to the power of 2 over 2. And then if I multiply negative 2 times 2, I get negative 4. Okay, so again, when multiplying by the conjugate, you just multiply your first terms and your last terms. Okay, now I can simplify. So if I have y to the 2 over 2 power, that's just y. I have plus this 2y to the 1/2 and 2y to the 1/2.
4y?
Is 4y to the 1/2. Just like if it was 2y squared plus 2y squared, it would be 4y squared. And then I still have plus 4. This is over 5y to the 2 over 2.
Yeah, that's just y.
That's just y.
Yeah, we got minus 4.
And then just minus 4. Okay, and I could leave it like this since I started with rational exponents, or you can change this y right here to the square root of y. That works too. Otherwise, this is simplified. Okay, so at the bottom there, for expressions with rational exponents, an expression with rational exponents is simplified when all of the following conditions are met. So it's good to go back and check these conditions as you work through problems. So it has no negative exponents. If it has a negative exponent, it flips it to the denominator or flips it back up to the numerator, depending upon where it is. It has no exponents that are not positive integers in the denominator. Okay, so meaning it has to have that whole number exponent in the denominator. If it's a fraction, you need to rationalize the denominator. Okay, so if you have that fractional exponent in the denominator, you need to simplify. It is not a complex fraction. The index of any remaining radical is the least number possible. Okay, so you want it to be that least number possible. So in this case, you have the cubed root. Okay, can't get any less than that. Any questions?